Welcome to SSI Meetup. Today we have Nathan George with us. He's the CTO of the Sovrin Foundation and obviously also Hyperledger Contributor. We will learn more today about the relationship between the Sovrin Foundation and the Hyperledger community and the many other things they're doing there. And we're just going to quickly review in the second slide what SSI Meetup is about and what we're trying to achieve and do here. So we're just going to click through. And as you know, for those that have joined us before, SSI is about empowering the global SSI communities, and it's really open to everyone. If you're an individual anywhere or a company or community, we hope that you can reuse this content to build up your own SSI community, so just build up your own knowledge and do presentations about SSI. All the content is being shared with the Creative Commons by share alike license, which basically means that you can reuse the content and you just have to give credit back to the person that shared the content, which today is Nathan George from the Sovrin Foundation, and please give credit to SSI Meetup too. And we will share the Google slide deck link where you can download the links, the video, and also slide share link that you will be able to use. This is our program number 30. We've been around now for a little bit more than a year, and it's a pleasure to have Nathan here with me. I've known him now for, I think, almost 2 years, and thank you so much for coming. And just one more thing I forgot to say is if you have any questions, please just drop them in the question tool. If they're relevant for the moment, I'll bring up those questions to Nathan at the same moment. If not, we'll just try to keep them at the end, so you will have plenty of time to ask your questions. So that's basically it. Same setup as always. Nathan, thank you so much for joining us today. Really look forward to learn more about Hyperledger Aries, but there's so much more to learn about the Sovrin Foundation. But Hyperledger Aries and in general understanding more about the Sovrin Foundation is a great start. Thank you so much, and the floor is for you now, and we look forward to hear what you have to share with us today.
Thanks, Alex. So like you said, I'm the CTO of the Sovrin Foundation. I'm also on the technical steering committee at Hyperledger. Hyperledger is a Linux Foundation project, and there's lots of different software tools and projects hosted underneath the Hyperledger consortium. In particular, the Sovrin Foundation helps to facilitate and sponsor the Hyperledger Indy project, and now also the Hyperledger Aries project. And we have also done a lot of work to facilitate and sponsor the Hyperledger Ursa project. And we'll get a little bit into all the differences between what those are and talk a little bit about the technology and the use cases that each of those address today. But in particular, seeing as this is the SSI meetup, we'd like to talk a little bit about self-sovereign identity and what Sovrin is doing about self-sovereign identity and how that relates to Aries and how that relates to something we call identity agents. Decentralized identity is not about blockchain. It's really about trusted information flows and trusted information exchange. And one of the things we found as the Hyperledger Indy community grew is that being a system that does blockchain identity means that people often incorrectly focus on the blockchain component of the system. But as you start to build out applications and solutions, it turns out that this information exchange layer between different parties is the most important part of your infrastructure. It's the thing that needs the most sweeping integration work. It's the thing that ends up doing most or powering most of the actual use cases that you tried to build using a decentralized identity platform. This idea that Alice can talk to Bob and they can share information with one another in a way that's trusted and secure. We usually call this layer of the system the agent layer of the system, and we'll get to why in a little bit, but the essence here is that Alice has their own identity domain or their own context where they understand what it is they're saying and what it is that they're committing to, and they want to transmit or share information with Bob so that Bob understands that information or can verify that information according to what Alice meant when Alice decided to share or communicate. You'll often get into things like semantics or what is shared meaning in terms of the information processing as the data is transmitted between the two parties when you start to think about the essence of this problem. And that's really where the blockchain bit comes from, because what happens is that Alice needs to leverage data from some other relationship when talking to Bob. Alice doesn't just want to tell Bob that she is someone that's going to be a good customer for his service. Alice wants to prove it. Alice wants to prove that Carol believes that I'm a good customer for your service, or that Carol says that I will pay on time, or Carol says that I am a valid banking customer, and if you go talk to Carol, you'll be able to collect the funds that I promise. We often call this concept transitive trust, this idea that you can take and leverage the secure information communications you have in one relationship, in this case between Alice and Carol, and then prove and leverage that relationship when talking to Bob. This poses a lot of interesting challenges. In a centralized system, this is often solved by creating one oracle or one source of truth for all the data, and then doing all the data processing in a centralized way. Oddly enough, a lot of smart contract systems fall into that same category. You centralize all the data semantics on one decentralized system, meaning you take all of the namespace of information that can be processed and you formalize all the state transitions that are allowed by creating a state machine in a smart contract. And that smart contract only allows certain state transformations and certain information to be stored and processed on that decentralized system. And while that makes the system itself quite decentralized, it centralizes the semantics of the meaning of what can flow. And that's the opposite of what we want when we start talking about decentralized identity. We really want that shared language to be contextual. We want Alice and Bob to be able to talk about whatever they would like, the way they would like, without any other third parties or influences dictating how that communication must or must not occur. When we look at traditional identity systems, that's where some of the main failings end up coming in, is if Alice, Bob, and Bob can only communicate the way Carol wishes them to communicate, either Bob or Carol will start to dictate the terms or the semantics of how information flows between the parties and centralize the data inside of their own system. And you end up with the kind of this sucking sound where all the correlatable data ends up in one place. And pretty soon, parties to the transactions lose control and lose the ability to influence what they can or cannot talk about and with whom their data is shared or with whom their data is correlated. To avoid that, what we want to do is we want to maintain this pairwise contextual nature of these relationships. Carol has a relationship with Alice, and Carol can decide what data she wants to sign when she issues that data to Alice. Alice can decide where to share and where not to share that data, and Bob can decide where and when to accept that data. But it's all built on this fundamental construct of key exchange and a secure connection, the same way we would think of it in any cryptographic toolkit. You'll often see Sovrin presentations and presentations from the Sovrin community and even other parts of the SSI community broken down this way, where we have a base layer with a public blockchain that can serve as an oracle. And if we go back to our previous slide, remember here that Bob needs to know that Carol is the one that believes this data was issued according to the following constraints, right? So Carol's going to issue this data to Alice that Alice holds, and when it's presented to Bob, Bob needs to be able to verify or check that Carol means what she said she meant, right? But you don't want Bob and Carol talking directly to one another, or Alice and Bob can't talk independently of Carol, right? Carol needs to make some assurance about the data that then Alice can present independent of Carol. And that's really what we get at when we start talking about this layer one of a ledger, is that this is the public oracle that allows us to pivot between different information contexts. If you think about it using classic computer science terms, whenever you think about recursion, you have your n case and you have your n plus 1 case, but to generalize that your recursion works, you need to have a base case to which you need to build off of. The whole purpose of the Sovrin network is to provide a non-correlating public utility that allows you to have that base case of cryptographic commitment so that you can then build all the private commitments that you'd like on top of it. Right? That way I can say that I am the real me, and when I issue Alex a credential that says he participates in the Sovrin ecosystem, that people can know that Nathan George, the CTO of Sovrin, issued this credential, and that the data is verifiable without them having to have a direct API communications channel to me directly. This gives me a way of pivoting between different information contexts without having to correlate myself to any one particular use case. When we start talking about how this network works in terms of multiple identity agents, it's okay to have more than one network. And especially as we work on the public standards, we want to be able to have different networks for different purposes with different rules for different use cases. But we still need this idea of some base case so that we can assure that we've done the pivot from one information context or one set of shared meaning to another one correctly. Right, that helps us make sure that we have double spent proof the identifiers correctly, and that we are actually making a cryptographic commitment to the system we intend to make it with. The next layer that is important to this is probably the most classic cryptographic problem that we've encountered in the past 20 or 30 years, which is the key exchange problem. We need to make sure that we have the ability to send secure messages point to point, and that we can then talk about data that's signed, and we can talk about it securely. This agent-to-agent protocol layer allows me to sign messages and allows me to reference things from those other third-party communications. This is that arrow we were labeling as information on the previous slides. And it turns out that this layer has a lot of interesting technology work that still has to be done. In terms of one of the biggest differences I think that self-sovereign identity can make to the community in general, we spend a lot of time thinking about verifiable credentials and about the transitive trust part of the problem, but it turns out that this peer-to-peer cryptographic key exchange part of the problem has even farther reaching effects in terms of the changes it makes possible. Simple things like when I buy an Internet of Things device, who is the owner or controller of that device? Is it me, as the person who purchased it, or is it the manufacturer that built it? When we have the ability to do secure key exchange and talk in a very routable and extensible way, we can turn the key management of the device over to its owner, and it makes a whole bunch of new use cases possible and allows us to build different network topologies than we've been doing in the past with Internet of Things, and secure things in much more flexible ways, in ways that accomplish the types of data longevity and the types of device longevity that you really would like to see as you start building out your own personal cloud. And that gets us to kind of the basis of cryptographic trust, this idea that each party in the system has cryptographic keys that can constitute different pieces of data, that can constitute different pieces of meaning, that can constitute different entities that you can interact or talk with. And this is kind of the essence of how most blockchain systems build cryptographic capabilities. Is the continuity of the data on the blockchain means that only certain state transitions can occur. And that means that you can trust the keys because you can trust the state of the ledger at any given point. When we start talking about self-sovereign identity, we're building that same type of a system not to accomplish continuity of the data on the blockchain, but the continuity of the identifiers themselves, so that the data can exist outside of the blockchain. So we move all the data out of the DID public blockchain layer, we push it all into these connections that happen agent to agent, and that allows for verifiable credentials and also tools that are built on top of things like verifiable credentials that enable human trust systems. So what this gets us to is we end up with this idea of a context-specific identity system. Like, let's say we want a system that shares driver's licenses. Well, we have certain issuers that have to follow certain rules based on certain governance authorities in order to become issuers of those driver's licenses. We have people who will hold those driver's licenses and who will present them to certain authorities according to the governance rules and the processes that are established for how those credentials might be used. That's an application of an identity system. The things that go into the blockchain, in this case Hyperledger Indy, are facilitating many of these types of context-specific identity systems, right? The blockchain is just that public oracle piece and that data model that supports pivoting between these different contexts. The place where a lot of the interesting things happen, or where a lot of the interesting developments happening right now, is in this agent-to-agent communications layer, this ability to message back and forth and route messages back and forth between multiple parties and multiple entities. That's what we call, that's the part of the project that we call Hyperledger Aries. As we built out all of this as one project inside of Hyperledger Indy, one of the things that happened is people would unnaturally focus on layer one. The first thing they do when they arrive at the project is they try to set up their own blockchain. They try to create multiple validator nodes, and they really, a lot of us misunderstood the allure of that. But because the blockchain's purpose here is not to store or hold data. It shouldn't be terribly significant to any context-specific identity system. The context-specific identity system has its own mechanisms for creating credentials and deciding what the rules are for how those credentials flow from party to party. The blockchain is really meant as a way of making a cryptographic commitment to pivot between those different relationships, not as the primary source of data in the system or as the main source of trust in the system. That's really deferred to the context-specific identity system up above. But because when people showed up at Hyperledger Indy, they'd see, oh, this is a blockchain project, let me start setting up a blockchain. They would focus unduly on creating validator nodes and on how the actual architecture of the ledger itself was built. And they'd forget and neglect the agent-to-agent connections and the credentials exchange part of the system that was actually going to help make them make their use case possible. And so as the development community has grown and as we've gotten more support in this layer 2 agent-to-agent protocol system, it was clear that splitting these two parts of the system into two pieces would facilitate a lot of different things for the community. First off, it facilitates a lot of the technical issues that we'll talk about in a bit. But more importantly, it facilitates a community discussion that I think is very important, which is that it really doesn't matter which public blockchain you use, you still need this idea of verifiable credentials exchange and this idea of pairwise connections to exchange keys and have trust between parties, especially if you're trying to do it in a non-correlatable way, because most of this interaction happens entirely independently of the blockchain or independently of your public oracle, which means that the standards work and the interoperability work here is just as important, if not more important, than any interoperability or standards work that happens in terms of the public oracle of its blockchain. And so being able to focus on these standards and on these interoperability pieces independent of the blockchain facilitates a lot of healthy behavior. Namely, it helps us understand how to be interoperable and compatible in the credentials exchange and in the agent-to-agent connections, irrespective or ignoring the differences we might need or we might have to accommodate in terms of the blockchain layer. So let's get into some of what I mean by that. Verifiable credentials exchange isn't the only thing that you can do in layer 3. Once you have keys at the edge where every identity domain, if you will, meaning a company or person, organization, a thing, when they have their own cryptographic keys and they can store and manage those cryptographic keys, there's lots of different protocols that can be accomplished on top of that. The one we talk about the most, I think, in self-sovereign identity is the verifiable credentials exchange layer. And of course, decentralized identifiers themselves with the DIDs, right? I have a mechanism for exchanging cryptographic keys and resolving who the owner or controller is over a particular identifier. And then I also have the ability to make commitments against those identifiers and establish that the signed data that's being distributed across the system is correct according to the issuer or the controller of that identifier. But there's other applications that are possible too. In the broader crypto world, we often think about exchanging crypto assets, meaning the idea that I have taken a cryptographic key or a cryptographic secret and I've used it to denote or denominate some resource or some cryptographic capability. And I may need to exchange or trade those resources amongst different entities that own and control those secrets. So things like payments in cryptocurrencies is something you could consider an application at this layer 3. But there's more than that. There's lots of different APIs and interactions that can be possible using this transitive property of verifiable credentials. And we want to be able to accommodate lots of different things and lots of different extensible use cases and all the different creative solutions that people are coming up with. And by having a connection layer that's interoperable, it allows these different protocols to become interoperable more broadly across systems, and also it helps us to build cryptographic systems that are resilient and that follow best practices across even a lot of our disagreements in the community. So that gets to maybe a bit of a history that the broader SSI community may not be aware of. We've been working on this idea of identity agents for quite a long time. I'm not going to hit on a lot of the early history, but we are going to hit on a few, I think, of the main milestone events that have happened. In particular, I need to give credit here to Sam Curran and to Daniel Bloom, two of the guys that work at the Sovrin Foundation to help support Hyperledger Aries. They've built some of these presentations to give both at meetups that we've had inside for the Hyperledger Aries community and also for training sessions that we've done for the Sovrin Alliance. The Sovrin Foundation is an open source nonprofit. We support identity for all. Our goal is to create a public utility that everyone can use for whatever they want to use it for. And we sponsor and support work to make sure that the ecosystem remains vendor agnostic and neutral, that we're applying the best ideas that we can draw on to create an identity infrastructure that everybody can use, regardless of who came up with the idea or what vendors are behind it or what their use cases or interests are. So we do a lot of things to try to facilitate and make sure everyone can collaborate and contribute, especially at the projects at Hyperledger, and also to make sure that we've facilitated everyone being able to get their requirements heard and make contributions towards those requirements within the community. So we sponsor a lot of the build infrastructure, and we sponsor a lot of training and support material. One of the ways we do that is through something called the Sovrin Alliance, where organizations help to support our work as a nonprofit. In return, they can get a bunch of benefits in terms of us being able to help plug them into the community and bring them up to speed more quickly in terms of being able to participate. Some of these events that we've helped put together in the past are first, we've been for a long time sponsoring something called the Indy Agent Working Group Call. As the community grew, we started out not being part of Hyperledger. We started out directly at the Sovrin Foundation sponsoring a weekly call, once a week doing ledger work on layer 1, and this on the opposite week doing agent work, which was layer 2 and everything above layer 2. And it became really clear very quickly that we had not enough contributors at the agent layer, and that we needed a lot more tools than we had. And Evernym did a lot of work to build out and support a lot of infrastructure in terms of the Indy SDK to help support that agent ecosystem and that agent layer. And as that community grew, with Brigham Young University and the British Columbia government and many others coming to participate, we split that work off into its own working group we called the Indy Agent Working Group. And we started working on standardization and infrastructure well beyond just the SDK. And that led to some in-person meetings where we were able to ratify a bunch of basic standards about how these agents, these edge pieces, could talk to one another in an interoperable way, regardless of who developed the code base, and help build what we called a connection protocol, and build out message types and message infrastructure. And this led to the idea that we really needed a neutral or a fair way to say what meets or matches the protocol across these different companies. And one of the things that the Sovrin Foundation has been working on is facilitating a test suite so that everybody can certify against kind of a lingua franca across agents. It's not comprehensive. It doesn't include everything an agent could possibly do, but at least helps us know that agents have kind of a core set of protocol that they speak to make sure that they can understand each other to do that basic key exchange and start to do verifiable credentials exchange between each other. And that, of course, led to a lot of development work. In February of this year, we had a Connectathon. This is patterned after the Bluetooth and the HL7 Fire Connectathons, many other standards communities that you probably have heard of, where all of these different organizations brought their implementations of sovereign agents, and specifically built on top of Hyperledger Indy and the Indy SDK, which is now being migrated over to Aries. And we tested them against each other and against the test suite to show that we could do basic pairwise connections, we could do basic chat protocol, and we could do something we call a trust ping to make sure that you can do relayed secure messaging across multiple identity agents. That event was very successful. We had 6 independent agent implementations that passed the 3 tests that you see here. Established the basis for some of what came next. With the Internet Identity Workshop this year, we had a bunch of independent implementations that showed that they can do credentials exchange. And then we started a lot of important efforts with the broader community, the folks at DIF, Jolacom, and Uport and others, with ratifying and figuring out how to make sure that these standards we've been working on inside of the Indy Agent Working Group could be compatible across the broader community. And with that, we also announced the launch of the Hyperledger Aries project. So let's talk a little bit about what Aries is specifically. We talked already a bit about how I have my own information that I want to manage. I know what it means. I want to communicate it to some other party, and they need to understand what I mean when I say something. And they want to take that information that I give them in terms of credentials, and they want to present it to other parties. An agent is that software that helps manage and control a user's cryptographic keys and secrets, and track the digital information that on behalf of the identity owner. Right? I don't sign pieces of cryptographic information using my brain or pencil and paper. I have some software that represents me. There's a lot of controversy in the community about what that piece of software could be called. Some people call them identity pods. Some people call them identity hubs. Some people call them personal data stores. All of them share a lot of things in common, but they focus on different aspects of the problem or different aspects of the system. We, in particular, in Hyperledger Indy and now Hyperledger Aries, and then also at the Sovrin Foundation, really focus on this word agent for an important reason, that those cryptographic secrets and that information is owned and controlled by the person who received those credentials. And that software needs to act on their behalf. If that software does not act on their behalf, then a lot of the cryptographic value of the system goes away. I don't know whether that data is being presented by you, or if that data has been stolen or presented by some other third party or by some vendor with or without your consent. One of the points of this idea of transitive trust for verifiable credentials is that I do have the ability to build a system that can create the idea of consent, that I can know that you shared this data with me, that no one else could have shared this data with me. And that's really key to building systems that are GDPR compliant and to building systems that are really decentralized in the way that we'd like, because if we don't have this construct of consent, we don't have this concept of continuity of cryptographic keys, we don't know whether the system's any better than anything we've done before. We really haven't achieved the goal we wanted of decentralization because we don't know which parties we're interacting with when or why. And so one of the core components of an identity agent is this idea of a cryptographic wallet that establishes that continuity and that the user can own and control. So we have this idea that there's a ledger at the bottom, we have this idea that there's credentials exchanged at the top, and then we have this idea of decentralized identifiers and agents that can talk to each other to help glue these pieces together. So when we talk about this idea of decentralized identifier communications, we have verifiable credentials exchange, we have decentralized key management, right? Because I need to know that the keys are owned and controlled by you, and that if you lose your keys, you can reclaim those identifiers and continue to interact with me. We also talked a little bit about payments, and we talked a little bit about these other applications that are coming along. All of these need the ability to have a ledger that supports them. In particular, the Sovrin Ledger is a public instance of a ledger that can do this and can accomplish these different data models. And Aries, as a project, has been focused on the different mechanics of how to accomplish all of these things, right? So to talk about it in a mechanical layer, we need to be able to exchange DID docs or DID documents so that I know how to resolve your keys, you know how to resolve mine. I need to be able to make sure that I can send messages across those cryptographic keys. So I might want to send those messages just peer-to-peer, or I might want to route them or message them through parties like an agency or some other cloud infrastructure that is always online, because my edge agent may not always be online. And
Nathan, just one little question that came up here from Jan, and he was asking, just let me find the question. He was asking, you mentioned before that crypto payments are done on layer 3, and then he's saying, as far as I understand it, in layer 3, it doesn't need to trigger blockchain transactions. How do you work around the issue of double spend, especially for blockchain when you're on layer 3? And then he has a follow-up question. I'm just going to bring it up at the same time. Yeah, now just maybe you can first answer that one, and I go for the second one, which seems to be different.
No, Jan's question is exactly is a good one. Payment here that I'm talking about is how do I prove that I have paid in conjunction with some other activity, which is subtly different than what I implied before, right? It's not the idea that I'm just transferring Bitcoin to you. It's that I'm proving that this Bitcoin is associated with some other cryptographically signed data or information that I'm exchanging. So you're right that the double spend proofing of a cryptocurrency is something that you would do on the Oracle. For instance, I would prove that that this address has a sufficient number of Bitcoin in it, and then when I transfer it, I'm actually using my cryptographic capability with the ledger itself to trigger that state transition on the ledger to move some balance of Bitcoin from one address to a new address. And that's something that happens on that blockchain, not something that happens peer-to-peer. But payment as a more generalized construct is more interesting than that, especially when we start thinking about edge chain protocols and when we start talking about protocols that may not have to be double spend proof directly on the ledger at every step, things that are accomplished through something like the Bolt protocol. Payment actually can be a more generic interface that doesn't always require ledger-based double spend proofing. And so what I'm talking about at the DIDCOM communications layer in terms of payment is really that part of the system, this idea that I might want to prove along with my credentials exchange that I've paid you in Bitcoin in order to receive this proof, or that I've paid you in Ethereum, in Ether in order to do this particular transaction. And that gets to some of the constructs or ideas that we might see out of something like the Quilt protocol with the Hyperledger Quilt project. Excuse me, not the Quilt protocol, the Interledger protocol, excuse me, that's being built under Hyperledger Quilt, where that could provide an implementation that fulfills a more generic payment interface. And really what that gets at here is that we have a shared crypto library with Hyperledger Ursa that can do, where we're working on hardware-based security for a wallet and secure storage and secure secrets management. And by making it so we have more generic and more extensible interfaces for these different kinds of use cases, we can start to leverage these pieces of shared infrastructure across different parts of our blockchain ecosystems. So we can take something like the Interledger protocol and use it in a more generic way on top of something like credentials exchange. Or we can take something like credentials exchange and leverage it for things like KYC use cases when we do payments.
Okay, just one more question that we have in relationship to this too. Like Paul is asking, do you see agents as potentially functioning as escrow lockers, where they would be, where would be a state change may trigger the release of held assets to the requesting party?
Absolutely. In fact, as you start to look more and more at identity agents, you'll start to see that as you do an identity agent for an organization or for a person with lots of different compute infrastructure, they start to look more and more like a blockchain, where the types of things you'd think of as a smart contract are really the state processing or the data execution layer that goes inside of an identity agent. And that gets to a lot of the similarities that I think will emerge over time between Hyperledger Indy and the blockchain components and Hyperledger Aries and the agent components. Is that I think right now we think of Aries as the agent extension that goes on top of a decentralized system like a blockchain. I think over time we'll start to think of that in the inverse. We'll start to think of Aries as the infrastructure or toolkit that you can use to build lots of different kinds of blockchains.
Great, thank you so much. I think we can continue. There will be more questions coming up during the presentation.
Well, and feel free to stop at me at any time and make sure you send your questions in. Obviously, if we drive things on questions, I think it's a lot more enjoyable discussion, and you don't have to hear me go on too many different tangents. But like I mentioned before, lots of different blockchain platforms had the need for shared cryptography. The idea of infrastructure for zero-knowledge proofs or other zero-knowledge cryptographic techniques as are being built in Ursa's ZK library or the ZK Lang layer that we talk about inside of Hyperledger Ursa. Also, the idea of having generic constructs or interface layers for doing different cryptographic curves for different key management systems, and also doing different sharding techniques for keys and other cryptographic support that can be shared across lots of different blockchain systems is happening at Ursa. And that community is really active. We're seeing lots of participants across not just the platforms at Hyperledger, but across other cryptographic systems. Their calls are very well attended. If you have folks who are working on cryptography or who are interested in zero-knowledge proofs or cryptographic systems, I highly recommend coming to attend the Hyperledger Ursa call that happens on a regular basis, as well as the Sovrin crypto call, where we talk a lot more about tokenization of and tokenized credentials, and also some of the more advanced cryptographic things going on around anonymous credentials to make them more efficient. And then, of course, now the things that sit above this idea of the secure data wallet store interface, this DID comms communication layer, and of course, having a pluggable resolver layer, not just a resolver layer that talks to Hyperledger Indy and the Sovrin networks, but a resolver layer that can talk to multiple different systems, like Hyperledger Fabric, Hyperledger Sawtooth, something that could talk to something like the Interledger protocol, that could talk to an Ethereum-based blockchain, that could talk to BTCR methods. Those are all in scope for the Aries project, because the Aries project is really focused on that standardization of the DID communications layer, and not in terms of the standard, but in terms of code implementation. Being an Apache 2 open source code implementation that anyone can draw on or use, and then be able to talk verifiable credentials, not just using Sovrin or Indy style verifiable credentials, but using all the different kinds of or flavors of verifiable credentials we've been working on the W3C for some time. So the idea is to get a lot of the implementation work moving forward faster, so that we can support the types of standards work that we've been working on and hoping to make a lot more progress on at places like the W3C. So I'm just going to keep plowing through here. And when we just talked a little bit about these resolver layers, so I should make sure I advance my slides as I talk. But one of the important things to emphasize here is that really the idea with Aries is that you can route any of these things in a peer-to-peer way. You could also route them on multiple different kinds of blockchains. So I can store the cryptographic commitments I need just in peer-to-peer wallets, and I can do a lot of things without needing a blockchain at all, because I want to minimize my blockchain usage, and I want to use the best blockchain for the job that I have at hand, right? When I'm doing a payment, then obviously I probably need to have a resolver that goes to a system that's doing the right double spend proofing for whatever that payment is. When I'm doing verifiable credentials exchange, I want to make sure I can check on something like a Sovrin or an Indy ledger to make sure that the cryptographic commitments are correct and that no one has shifted the meaning of the credential out from under me, because I don't want to present a credential that means something different than what I expect. So the whole idea behind Hyperledger Aries is that it's peer-to-peer infrastructure for it's infrastructure for peer-to-peer interactions. It uses blockchains as a tool to facilitate those interactions, and it uses it when it's necessary, and it doesn't use it when it's not necessary. It supports more than one blockchain through the resolver interface layer. We hope to incorporate a lot of the work that went into the design and building of the universal resolver at DIF to turn it into a native C-callable library that can leverage multiple blockchains, so that we don't have some of the same portability issues that we've had with the universal resolver, or some of the same trust infrastructure issues where we would have to trust the resolver itself in order to accomplish data resolution. It provides a secure data store interface that has a vetted cryptographic library and provides tools to integrate into the best security on the different platforms that it supports. The idea being you want to integrate with whatever secure enclave technology you have available. And it does so facilitated by the Ursa library, which has been vetted by a broader cryptographic community that can be provided by any one platform on its own. And that supports and facilitates the standardization work that we need in order to make deployment easier, to make it so we can do encrypted messaging in an off-ledger way, and to make it so we can do zero-knowledge proof-based verifiable credentials and other decentralized key management pieces of infrastructure that we really need to be able to reuse and leverage in order to accomplish the domain-specific or context-specific trust systems that we talked about earlier. So with that, I think it's a good time to pause for any more broad or general questions. And there's a bunch of slides that I have here that we can get into based on kind of what direction you guys want to take the conversation. All the way from how we expect to move code from Indy over into Aries, to things about how the logo came to be, or how key introductions work, and how communications and message routing have conversations have been going. So let's go ahead and open it up for questions and give everyone a little bit of time to get those into Alex. And if there aren't questions, then I'll get to answer whatever questions I guess that you might have.
There are. I have a couple here lined up. Cool. First one here from Jan, and encourage anyone to please send in your questions. Jan is saying, I like the idea of an agent that's under the control of the owner of the key. However, I'm not sure when mass adoption will be possible because of lacking usability and dire implications when losing the agent. What do you think about agent services that do the hard lifting for the masses of users?
I think that the cryptographic systems need to do the heavy lifting for the users. I think that you should, if you have to think about your cryptographic key management, you probably will be too lazy to do it properly. One of the whole design goals behind how Sovrin and the Indian Aries projects are architected is to make it so that cryptographic key management fits and matches more closely to human relationships. Meaning making it so the cryptographic keys parallel things like contacts and things like information storage so that the system can automate away the complexity. And you can think of it just like you would think of any of your real world human connections, right? Our human brains are not very good at thinking about cryptographic seeds and, you know, derived keys and all those sorts of things, but we are pretty good at thinking about, you know, I know Jan and Jan knows me, and if I want to stop talking to Jan, I could cut off that connection and you know, shun someone, or I could ask to be connected to or invite someone like Jan to talk to me a lot more. And that really the cryptographic management, the infrastructure should be subservient to that type of UX or that mechanism that the human wants to use to think about it, not the other way around. So part of the idea here is that Aries should help us abstract away some of that complexity so that what Jan's proposing is easier to do. I would also say, though, that Sovrin in particular is not doesn't endorse any one vendor. It's a protocol that we want anyone to be able to talk and anyone to be able to be compatible with. So some systems may do a better job of this than others, and we really hope that there's a lot of interesting competition and innovation in this space going forward. I know that companies like Evernym have done a lot of work to try to do what they want to do with this type of cryptographic key management, and I know there's lots of other companies in the space that have their own designs on how to best facilitate that. And you know, I hope that the more secure systems and that the more usable systems win out over the systems that are lazy.
Cool. Doug is asking, can you explain further the trust needed in the resolver? Currently, I'm working with the Java code-based resolver created by Curtis S.
A resolver has a lot of the same problems that we've seen forever in the DNS system, and also in the traditional PKI certificate authority system, because you need to know that something is true back to the source or root of trust of that system. In most cases, that means you have to validate that the blockchain as a whole agreed to something. It's not enough that the resolver can answer the question of what DID document matches this identifier. You need to know whether it's the right DID document that matches the identifier as of today, according to that ledger. And that gets to how do you validate or prove that you're not on a fork, or that you're on the right fork in the case that forks are allowed or encouraged on your system. And so different DID resolvers have different qualities or capabilities when it comes to that. In particular for Indy and Sovrin, we have the idea of a state proof. And so the client itself can validate that state proof to know that the data is correct as of a certain timestamp according to the ledger as a whole. And that helps tremendously because it means that the client can do the verification even if you go through multiple hops. So it doesn't matter who returns the data from the ledger. When I receive that data at the edge, I can prove that the data is correct. If you don't have that ability, there's a lot of interesting phishing and man-in-the-middle attacks that are possible, because I can set up a dummy network and then proxy your requests and your connections and substitute out keys on you. There's a lot of interesting discussions we can have about how to accomplish a resolver that doesn't have those problems. It's actually really difficult to do that with some of the conventional blockchains that are proof of work based blockchains because of the probabilistic forking, but it's not impossible. And that's a conversation we hope to continue in the Indy community and in the resolver interface in terms of how we model the trust capabilities. Rust has a lot of interesting capabilities in terms of traits and type traits that could reflect some of these trust qualities, so that when I say, hey, I need a cryptographic guarantee about what this credential means, I could ask for some of those guarantees in the type traits so that only resolvers that are capable of that type of trust could fulfill that request. That way I can be more pluggable and more extensible so that as ledgers come up with new ideas for accomplishing those trust qualities or trust traits, the system becomes more interoperable.
Thank you. Question from Jan. He's asking, what makes Indy better suited for decentralized identity compared to Ethereum?
I don't want to start that flame war. There's a lot of different qualities between those systems. Some for better, some for worse. In particular, this construct of a state proof, and basically fast forwarding past the idea of proof of straight to a proof of authority style system where Sovrin was built from the beginning with strong governance that's community based, so the developers can't run away with the control of the system, and so that identifiers are the only thing that go on the system, and that the data is pushed off of the ledger so that it doesn't end up correlating you to any particular smart contract set, is really important to us. I think that the idea that the system has a permissioned quality helps quite a bit in terms of being regulatory compliant with a lot of different use cases, but really the permissioning was, this is one of the unfortunate misunderstandings I think we often have with both the Ethereum and the Bitcoin communities, is they see it as a permission ledger and say, oh, that has people that will tell me no. The system's actually designed in the opposite way. The permissioning is meant to be a tool to facilitate efficiency and low cost, in a way that makes it so no one gets control individually, right? It's meant to select the most diverse subset of possible organizations running nodes to make it so that you can get a very cheap and efficient state proof, which I think you'd see a lot of parallels with that and a lot of the proof of authority type constructs that have been thrown around in the Ethereum community for a long time, but not necessarily adopted fully. And so, there's also a lot of terminology mismatch between the two communities in terms of how we talk about governance structures and how we talk about centralization and trust versus trustless systems. That I think we should do more work to bridge that gap. But I think you'll see, I think, more in common than different, especially when you focus on this agent-to-agent communications layer that is Hyperledger Aries and the credentials protocol. But I hope that both sides can keep an open mind, because there's probably a lot of commonality and a lot of shared resources and code that we can make faster progress with as we work together.
Thank you. Tobias is asking, can you share an example of how an organization is using this to solve current problems they have and improve the user experience?
So there's a lot of different places that this can be applied. Some of the best ones have been really surprising to me. One of the examples we like to point to is the credentials ecosystem that's going on in British Columbia with what the BC Gov team has built called a credentials registry, or a verifiable organizations network, where instead of trying to get all the identity holders on board to own and control their own cryptographic wallets, what if you just focused on the issuers and you focused on letting the issuers verify data from other issuers? Meaning, if we just take all the data that's already public, we sign it as verifiable credentials and put it into a shared repository so that everyone can verify data from everyone else, we create we can bootstrap just the first half of the two-sided marketplace for verifiable credentials, where the issuers want data that's got better validation than what they can get now. And because that data is already public, they can do something with the credentials registry to make that data flow between parties. And that creates basically an ecosystem of a lot of credentials issuers that then other people can draw on, right? You need to create use cases where it won't succeed if one person, or if everyone adopts it. It succeeds if just one person adopts it. And so if you haven't looked at it before, I encourage you to go look at vonx.io and take a look at the excellent documentation and support work that the British Columbia government team has put together around their system. But there's other use cases too. There were a lot of really great demos done at the last IAW around ideas for verifiable credentials. In fact, I think Tobias may be softballing some of these questions, because I think if it's the Tobias I'm thinking of, his organization has a bunch of really cool demos around e-commerce demonstrations, and also use cases around how Internet of Things devices could do self-sovereign identity type authentication. So I encourage you to go exploring. If you go to Hyperledger and go to right now it's the Indy agent repository, and the README there references several different organizations' agents. Go poking around and see what use cases that they're solving for. There's a lot of interesting things going on in the community.
Thank you. Ed is asking, where does DKMS fit into the earlier picture? Are the implementations of DKMS consistent with Indy Sovrin?
So decentralized key management systems is one of the things I'm hoping that more people will show up to help code and build. We've been working on the architecture for it for a long time. We have a lot of good thinking there in the community that's ready for development, but we don't have a lot of bandwidth to tackle it. There's a few new data objects we'd like to add to the ledger to make it so that you can do remote revocation of an identity agent. Let's say you left your phone in a taxi and it drove away. You want to be able to go and revoke the ability of that agent to act on your behalf. And so there's a really great paper that's hosted inside of the Indy Hyper repository that I think it's also being or has been migrated to the Aries RFC repository around how decentralized key management systems can be built on top of the system. We're in the process right now of doing a major upgrade to the zero knowledge proof capable credential system inside of Indy and Sovrin that will include some of those new data model objects, or will accommodate those data model objects better. So if anyone's interested in helping participate in that work, we are looking for developers to help code there. It'd be a really great opportunity to get involved in ledger transactions code, and also the data model for peer-to-peer credentials exchange. If you want to reach out to the Indy Semantics Working Group for that, Ken Ebert, who works for the Sovrin Foundation, is trying to help coordinate some of that that coding effort. And I know that Evernym has been participating actively with that, with Brent Zendel helping out. And then there's some others in the community who have been consulting on those standards. We're hoping that more folks will step up with some coding resources, because we'd like to get that scheduled in terms of a sprint plan and integrated into the system as fast as people are willing to help accommodate it.
Okay, thank you. Just to follow up here, like, I don't know if this helps. Jan, he's commenting that with agent services, he meant centralized agent services that are managed by middlemen. He's saying that he's not sure this came across.
Centralized agent services that are managed by middlemen always have the downside that you never know if you're dealing with the actual end user or if you have the end user's consent. The way the agent architecture works inside of Hyperledger Aries doesn't require that degree of centralization anymore in order to accomplish what you need to accomplish. It actually enables a whole kind of broader spectrum of semi-managed services because it allows this construct of delegation and has more infrastructure for key management than what you'd be used to from just, say, a cloud crypto wallet provider. There's a lot of exciting things going on with respect to how agent messaging works in terms of its extensibility and the ability to create different APIs that can be accomplished with multiple units of computing. We draw a lot of inspiration off of a previous system called Picos. It was actually Phil Windley's, one of his startups, built out a lot of infrastructure for shared personal cloud computing. That we draw some constructs from when we start thinking about decentralizing the agent infrastructure for any one individual organization or thing. So I would encourage those questions at the Indy, what were the Indy agent calls, now the Hyperledger Aries working group calls, which happen on Wednesdays. We have a lot of discussion around exactly those topics.
Awesome, thanks. And follow up from Doug also, like regarding the resolver. Do you see role for zero knowledge proofs in the resolver space?
Absolutely, and this is one of the overlaps between a verifiable data registry and an identity agent, is that a verifiable data registry is actually an identity agent for the public. It's basically a shared context that anyone can write to, and you want to know that the shared context agrees that this data is true, right? So you can think of the blockchain itself as if it were another identity agent, and that the data that it stores on the quote-unquote ledger of that verifiable data registry is essentially a collection of credentials that it's the holder for, where the issuer is the owner of the identifier, and they issue it to the shared registry that is the verifiable data registry. When you start thinking that way, it blurs a lot of the lines that help simplify how we think about this is the ledger part of the system and this is the agent part of the system. But it also points out that the ledger right now lacks some qualities like revocation that help with GDPR compliance. And so there's, I think, some important work we can do to help clarify that language and improve that part of the system as a result.
Thank you. Paul is asking, is Hyperledger Aries an opportunity to pitch pairwise encrypted channels of communication rather than just being pitched as an identity solution, which is not always the easiest sell?
In fact, it's not really an identity system at all. It's an identity meta system. And this idea of verifiable information flows is the core functionality of the system, much more so than identity itself. And that's been a hard thing for us to figure out how to message properly. So if you have ideas about how we should better communicate that, I would love your help.
Okay. Salvatore is asking something I'm not sure I understand, but maybe you do. What if the legal status of the signer as opposed to the certificate status and key change in the chain?
Well, this is one of the differences between an contextual identity system. Let me see if I can go back to one of the slides that we have that talks about that. This is one of the differences between an identity meta system and a context-specific identity system. Is context-specific identity systems make guarantees about things, right? They have governance authorities and they have registries and auditors that prove or try to enforce certain qualities about the attributes that flow in the system. An identity meta system makes no such guarantee. Right? In order to be censorship resistant, anyone needs to be able to say anything. I could issue you a credential that says you're a neurosurgeon. And if someone relied on that credential in order to let you perform neurosurgery, they would not be very smart. But anyone is allowed to say anything. It's up to you to decide whether and how you'll trust them. And this leads to this idea of a chain of credentials, right? I might give you a credential that says that I'm a brain surgeon, but you need to know, well, who issued that credential? Should I trust that entity to be credentialing brain surgeons? And then you would ask, you'd go to that issuer and say, you need to prove to me that you're an authority over brain surgery. And then you'd walk that chain of trust back to some entity that you understand or know inside of your system. That's actually one of the very interesting or important qualities of validator nodes inside of the Sovrin network, is because we actually only bind attributes on the ledger for the validator nodes and for the trustees. They serve an interesting purpose in terms of building out your own web of trust, because I can always walk it back to say, oh, this is a customer of IBM who's a validator node on the network, and I can tell that they're the owner of this validator node key that has an attribute bound on the network. And so it actually ends up simplifying a lot of the auditing at the general network layer, because there's so much less of it to do. We don't use it as a source of all truth like you would in a typical CA system. But it gives us multiple paths for a web of trust to build on, because I can say I can trust someone who's a steward organization, and I can verify to that, or I can trust the person who provides my agency and I can verify down to that, or I can trust some of the credentials issuers that I already know about, right? I can trust it back to my government entity who issued me my driver's license, or to my employer who issued me my employee credential. And by having multiple sources of trust in the system, if one authority of the system doesn't want to cooperate or has data in error, I can use these other sources of truth or other sources of trust to help triangulate whether I'm doing the right thing.
Thank you. A couple of questions from Jan. He's saying, thanks for the answer. I was worried that there are low-level technical differences that make it very hard to establish SSI on Ethereum, but I understood that this is not the case. Okay, I mean, this is more of a comment. Then another question around governance.
Another comment there on that, Jan. Yeah. There are some low-level things that make it very challenging. The state-proof type verification in particular makes it almost impossible to do offline credentials effectively. But that's something I hope to, if you know folks who are working on the problem on the Ethereum side, who are not engaged with us already, I hope that we can engage more deeply with them. We work a lot with the the folks that have been doing decentralized identity with Uport and Consensus. Those guys are really good at collaborating with the community, and we know a little bit about the problem from their eyes, but we would certainly like more perspective on how the folks on the Ethereum side are thinking about the problem.
Great. So then the follow-up question from Jan is around governance. So he's saying level 4. How's the integration of the governance structure implemented in Aries? Do you have a point you could share of how governance structures implemented, how they're implemented so that they're machine readable?
So right now, we have not done a lot to implement layer 4 in a machine readable format. Layer 4's work is primarily happening right now on the governance framework side, in terms of figuring out what the ontology and what the kind of the regulatory framework environment looks like internationally, so we know which pieces are compatible for a global network. And I expect that once we get through the next anonymous credentials 2.0 data model work that's happening now, that we will be adding data model objects to help support layer 4. So what's going to happen is the new anonymous credentials support multiple issuer credentials, meaning M of N issue signature schemes for credentials, and that means that things like private permission blockchains can now be issuers of verifiers or holders of credentials in the traditional sovereign sense, in the sense we think of it in the sovereign world, and that opens up some of these layer 4 objects to be more machine automatable and accomplished through decentralized systems as opposed through just automating them through legal agreements. So once the anonymous credentials 2.0 work is done, I expect we'll start seeing trust anchor objects that specify governance authorities, auditors, auditor creditors, and so forth. And those will start looking a lot more like smart contracts. Once we get to that point, we're also looking at adding double spend proof registries to the sovereign networks, which will mean you can do things that look a lot like what you would think of as an ERC20 token right now, but you'll be doing them in an entirely off ledger way, because the only thing the ledger will know about is the double spend proof oracle. And that would be protected by a ZK snark or by a bulletproof Merkle tree. So there's a lot of interesting innovation going on there. Again, the Ursa call and the Sovereign Crypto call are great places to engage in some of the more advanced crypto side of that discussion. And then the Sovereign Governance Framework Working Group call is a great place to engage in kind of the business ontology technical requirements building.
Yeah, there was just one more follow-up comment. I don't know, just for you to know if you want to comment on that. He was also saying also complex governance structures like government says this is a bank, bank says this is a customer. Now I want to verify the whole path from the customer to the government.
Oh, absolutely. And if you look at InfoCert out of Europe has been doing a lot of really cool work on this. I know that they released a bunch of stuff publicly a couple of weeks ago that talk a lot about IATIS compliance and also how a certificate authority can play a role in certifying or building out a web of trust for those types of use cases. So I expect we'll see a lot more about that as a general community over the course of the next few months.
Cool. Paul is asking, do you see Hyperledger Aries becoming an interoperable solution between any decentralized internet, decentralized data exchange initiatives, such as Ocean Protocol, Solid, Inrupt, and Polkadot Parity?
Well, I can only speak to my hopes and dreams there, and which is I certainly hope so. More of those folks from some of those, more folks are showing up at the project. Some of them we know about what they're working on and who they work for, and some of them we don't. Obviously, as people building decentralized identity, we don't require you to strongly identify yourself. So I can't speak to all the use cases or all the folks who are showing up to participate. And I also don't know where kind of their investigations will go, right? Some people come and look and take those ideas and go somewhere else. But I'm hoping that as a community, what we're building is enticing, and that participating on an active basis and on an ongoing basis is also enticing. In particular, as the Ursa community has become more self-sustaining and more involved, I think we're starting to see enough collective momentum that it's very hard to duplicate to come learn what we're doing and duplicate it somewhere else. And it's all designed from the beginning for anyone to be able to come and use it. It's all Apache 2 licensed open source stuff. And whether you decide to use the Sovereign network or whether you decide to pick and choose some of the pieces within the system, we're happy to accommodate all of that. And all we ask is to please participate in good faith.
Awesome. Salvatore is saying, just as a follow-up from before, and not only trust, but agency and consent. And thanks for the reply, he was saying. Okay, and then one more question from Ed. He is asking, when will the slides be available? They will be able probably today or tomorrow. I'll try to get that around as soon as possible. From Mike Brown, thanks Nathan for all this hard work in the community. You're really making such an amazing difference. So thank you, Mike, and that's for you, Nathan. And then also Alfonso was saying, thank you for an excellent presentation. Looking forward to the next one. Okay, so I think I have one more question here from Drummond, who's also saying that you did great, great presentation. He also has one question for you, and he's saying if I mean, I think this has been answered already. Maybe you want to comment a little bit more. If Aries should work across all blockchains.
So Aries is designed to work across all blockchains. As long as someone was willing to come up with as long as you're willing to fulfill the resolver interface, it should be able to talk to whatever your decentralized or centralized system might be. Now, we have not fully formalized that interface yet. That's the process that's underway right now, which means that there's an even better chance that it will work with your system. So if you want to come and participate in how that interface is defined, you can guarantee that it will work with what you're trying to make it work with.
Nice. One final question. If Aries is a peer-to-peer on the peer-to-peer level, could you envision a moment where a ledger blockchain or something like that is not needed anymore, and this could be like running only on peer-to-peer networks?
That's the idea. We want minimum viable blockchain. If there's a way of making it so that there's less blockchain, we'll do that, because the trusted information flow is really the point. Is that everyone can own and control their information and can participate equally with one another. And if we can do that using less blockchain, that system should be more efficient and it should win.
Wonderful. And do you see any other initiatives in the market taking this approach? Because, I mean, like peer-to-peer only driven SSI seems to be like the next stage, as you just explained.
Well, everyone's working on different kinds of side tree protocols. I think it's one of the dangers of some of the traditional token cryptocurrency type approach is the state on the ledger often ends up with its own inertia, and it's hard to push things off chain when you've built in those kinds of economic incentives to keep things on chain. And so I'm hoping that with open participation in the community, the way we're looking for and the way we push hard to make sure that that's preserved, that we'll be able to move faster towards getting to these types of edge protocols in a way that's not only extensible but readily usable. I mean, because it doesn't matter how intellectually pure or theoretically decentralized the system is. It matters that I can talk to lots of people and accomplish lots of things today, which gets to Tobias's question around use cases. We want to show that there's practical interoperability and valuable data to exchange with other real people on the network now. And it's one of the reasons why on the Sovrin network we're so eager to highlight and show the use cases that have gotten to the production network, and how you can interact with their credentials and interact with the protocol, because that opens up a lot of opportunities for integration where you're not bearing the entire burden for adoption or the cost of building out the network effect.
One more question that just came in. Do you think there's a need for, this is Paul, do you think there's a need for a wallet consortium to help with standardization for wallet type things?
I was hoping the answer to that was no. A lot of blockchains think of their client part of their system as an afterthought because they're tightly controlling either the permissioning of the network nodes themselves or very tightly controlling the smart contracts of the state transitions or the data applications themselves. They don't think a lot about how do people get to their system and how do people talk to the system. I'm hoping that by facilitating everyone can have a wallet and everyone can engage in messaging as an API, that it helps alleviate that need to build out your own client infrastructure on a per blockchain basis. That when people say, hey, I need to go get a place to store the following type of crypto asset, they know that they can just pick up something like a Hyperledger Aries wallet and just store whatever they want inside of it. And that generic capability will help everyone build on shared infrastructure as opposed to having to invent their own from scratch. But we're going to have to see how that goes. There's a lot of people building wallets in the ecosystem, and they're all doing it for the most part independently. I'm hoping that having more shared infrastructure means less duplication of effort and means we get where we want to go faster.
Wonderful. Thank you so much, Nathan. I think we did all the questions. We had plenty of questions today, which is great. Any final comments from your side or something you would like to share?
It's great to see so many familiar faces on these meetups. There's a lot of work going on in standards organizations, and there's a lot of great open source work going on in the Hyperledger community. I hope to see you all soon on those community calls and to get to talk to you again here at SSI Meetup.
Nice. Just for everyone else, we had a request from Paul is just telling me, tell Nathan that he's a great chap. So here you go, Nathan. I think you increased your fan base in the Hyperledger community even more. Thanks, Paul, for the comment from Nathan. Just for everyone to know, I just discussed with Nathan before that we will be doing an Asian session for this presentation or something similar, because there was a request to do the same presentation for the Asian time zone. So we will try to set it up in the coming weeks when Nathan is available. In the coming weeks, we have a couple of cool things lined up. We will have InfoMiner talking about the SSI community and its evolution. We will have the guys from Elements in Texas who are building a side tree like solution for on top of Ethereum, and we have Kim Duffy planned also for July. Plenty of interesting people, so watch out for that. We will be sharing all this information as always via Telegram, Twitter. Sign up to the newsletter to receive that information. I will be publishing this as soon as possible, today or tomorrow. You will be able to find it if you go to ssimeetup.org. Or if you go to the webinar 30, which is the one from Nathan today, you will find the video, the slideshare link, and the Google slide deck, which hopefully you will be using around the world to share the good news about Hyperledger Aries around the world. And yeah, and I think that's about it. Thank you so much, everyone who joined us today. Thank you so much, Nathan, for your great work in the Sovrin Foundation, but especially for the self-sovereign identity community. And I'll ping you to plan for this Asian call and look forward to do that again with you with plenty of questions from everyone.
Thanks, everybody.
Thank you.